Silas Maths.
The best place to learn mathematics.
Hi friend, welcome back to class. I believe you had a great learning experience in our previous class. Okay, in our previous class we talked about the first two laws of indices. We talked about the multiplication law and the division law. And remember what we said about multiplication law, that whenever two or more variables of the same base are multiplying, what do? We pick one base and add their powers. That is to say, if I have a to the power of x times a to the power of b, so what do? We go ahead and then pick one base, which is what? A, and add their powers, which are x plus b. All right. So if we have something like this, let's say for example we have a to the power of 7 times a to the power of 2. What do? We pick one base, which is a, and then add their power. 7 plus this will give me what? 9. So that is my answer. So we also went further to talk about the law of division, and we said that whenever two or more like variables or bases are what? Dividing, what do? We pick one word base and then subtract their word parts. So that is to say, when I have, let's say we have x to the power of 2 dividing what? X to the power of what? 1. What do? Pick one base, which is x, and then subtract their powers. I have 2 minus 1, that will give me what? X to the power of 1, which is x. All right. So in today's class, we are going to continue from where we stopped, and that is talking about the remaining law. Let's consider this law. Now let's talk about zero power law. Zero power law. What does this law state? The law states that whenever a number or a variable is raised to a power 0, the value will give us what? 1. All right. Let's say we have a to the power of 0, that will give us what? 1. That's simple. So anytime we are dealing with expressions or simplifying problems and we get to a point where that number or variable is raised to power 0, the value will give us 1. This simply means that 100 to the power of 0 is equal to 1. Any number at all, 2 million, 3 million to the power of 0, v to the power of 0 is equal to what? 1. That is what it means. All right. Let's take for example, simplify. Now, let's take a look at this example. Simplify this. All right. Let's simplify these two questions. The first one we have here is this. Number 1, solution. 2 to the power of minus 2 times 2 to the power of what? 2. Remember, the law says that whenever they are actually multiplying and they are of the same base, what do? We pick one base and add their word power. So this will give us what? Pick one base, which is what? 2, add their powers. I have minus 2 plus what? 2. Okay. Now minus 2 plus 2 will give us what? Will give us 0. When I say minus 2 plus 2, it's something as saying 2 minus what? 2, and that is equal to 0. So this will give me what? 2 to the power of what? 0, and the final answer is what? 1. Yes. Final answer is 1. Over to the next one. We have this problem. Number 2, 4 times 3 raised to the power 3 over 2 raised to the power 2 times 27. So in simplifying this further, we go ahead and express this in index form, and that will give us what? 2 to the power of 2, that is 4, times what? 3 to the power of what? 3 over what? 2 to the power of 2 times what? 3 to the power of what? 3. 27 is 3 raised to the power what? 3. So in solving further, we can do what? Subtract these powers and as well subtract these powers. Okay, so we pick one base here. This one, I have 2 to the power of 2 minus 2. Then for 3, I have times what? 3 raised to the power 3 minus 3. Right? And that will give us what? 2 to the power of what? 0 times 3 to the power of what? 0. And remember that any number raised to power 0 is 1. So this will give me what? 1 times 1, which is equal to 1. That's my final answer. Okay. So remember, also don't forget, you can actually use any form of variables for these problems, not only numbers. So far we've been using numbers, so we can actually use a variable as well. Okay. So let's say we have a problem like this. Number 2, simplify simplify, a to the power of 5 times b to the power of 6 divided by a times a to the power of 4 times b to the power of 3 times b to the power of 3, right? So this kind of problem as well, we are dealing with variables now. So for the numerator, this will give me solution. I have for the numerator, I have a to the power of what? 5 times what? B to the power of what? 6. Now this denominator, this is the same thing as a to the power of what? 1. Okay, let's write it like this: a to the power of what? 1 times a to the power of 4. Why this is times what? B to the power of what? 3 times what? B to the power of 3. So expressing this thing further, we go ahead and say that this is what? A to the power of 5 times b to the power of what? 6 divided by, these two are the same base, we add their what? Power. So we are going to have a to the power of 5, because 1 plus 4 will give me what? 5. Then these two are of the same base, we go ahead and add their power. So 3 plus 3 will give us what? 6. So at this point, we can actually use cancellation method to solve this problem. At this point, I can say that this man will cancel out this man here will cancel out this man. All right, so at the end of the day, the answer becomes 1. Or if I want to apply the law, using the law to solve this, I can say that this is now equal to what? A to the power of what? 5 minus 5. Since they are of the same base and they are divided, we'll subtract their powers, times the same base, so b to the power of what? 6 minus 6, right? And that will end up giving us what? A to the power of 0 times b to the power of 0, which is sending us 1 times 1. And 1 times 1 is equal to what? 1, the final answer. Okay, so that is that for that. So that's that for this particular law. Now the next law we are going to consider now is what we call, okay, let's clean up this part. Now the next one is what we call negative power law. Negative power law. What does that law state? It states that whenever a variable is raised to power a negative exponent, right? A negative power or a negative exponent, we take the reciprocal of that particular number, right, and raise it to the power of what? A positive power. For example, let's say we have something like this. We have x. Okay, let me use x this time around. X to the power of minus a. All right. So look at the negative. The power is what? Negative. So how do I remove this negative? I'm going to take the reciprocal of x, that is 1 over what? X. And then a, the power remains what? A. So 1 over what? The reciprocal of what? This particular number. So that is what? 1 over what? X raised to power what? A positive power. 1 over x raised to power what? A positive power. Is that okay? All right. So for example, if I have something like this, let's say 2 to the power of minus 3 or negative 3. 2 to the power negative 3 is going to give us, what? To remove this negative sign, it becomes 1 over, right? 1 over what? 2 to the power of what? 3, positive power. Okay, now that is to say that this 1 over has taken the position of the what? This negative sign, that is taking the reciprocal. Reciprocal simply means if I have 2, reciprocal of 2 is 1 over 2. 1 over 2, right? Because 2 is the same thing as what? 2 over 1. Every whole number is the same thing as what? That whole number divided by 1. So taking the reciprocal of these 2 becomes what? Inverting it, so it becomes what? 1 over what? 2. So what is the reciprocal of 4? It becomes 1 over what? 4. Right? So the same, different thing. That's the same with fraction. You know, when we have fractions like this, let's say 4 divided by 5, for example, reciprocal of 4 over 5 becomes what? The inverse. That's what? 5 over 4. That's the reciprocal. All right. So that is what this law states. And whenever we have this negative power, to remove the negative power, we take the reciprocal of that particular number inside, and it becomes what? This. So that will give me equal to what? 1 over what? 8. That is 2 times 2. I can say 2 times 2 times 2, and that's 1 over what? 8. Okay, so that's what the law says. Okay, so we can actually have series of problems or examples associated with this problem. Let's take, for example, we have this. Simplify. All right, let's take a look at this problem. The problem reads, simplify 2 raised to the power 5 times 25 over 64 times 15. So let's go ahead and solve. Solution. So that will give us 2 raised to the power 5 times 25 over 64 times 15. So we can actually express these numbers in index form. All right, for 2 is already in form of index form. So for 25 is something as what? 5 times 5, right? 5 times 5, okay, divided by, for 64 is simply 2 raised to the power 6. That is to say, 2 times 2 will give me 4, times 2 will give me 8, times 2 will give me 16, times 2 will give me 32, times 2 will give me what? 64. That is 1, 2, 3, 4, 5, 6. Okay, then y15 is something as 3 times 5. Okay, 3 times 5. So if we take a look at this, we can see that okay, let's go ahead to this part. So simplifying further, this gives us what? 2 to the power of what? 5 times 5 to the power of what? 2 divided by 2 to the power of what? 6 times 3 times 5. Okay, this time around we have a base that is on its own, but we can actually take these two, right? So applying the law, we can say that this is something as what? 2 to the power of 5 minus what? 6 times what? For this one, this is something as 5 raised to the power 1 and 3 raised to the power what? 1. So we can say that this is something as what? 5 to the power of 2 minus 1. Then for this one over here, we can say it's something as what? All over what? 3 to the power of 1. Since there is no other no other base that has this, so let's leave it that way. So this is going to give us what? 2 to the power of what? Negative 1. Because 5 minus 6 is what? Minus 1. Then the other one, 5 raised to power, that is going to give me 1. Then for this, I have all over what? 3 raised to power 1. So at the end of the day, look at what I have. I have this, so that means I can actually express this number here. This is something as 2 to the power of minus 1 times 5 over what? 3. 5 over 3 all to the power of 1. I can as well leave the minus 1 because it doesn't make any difference. So this 1 over here is the same thing as what? 1 over 2. Remember the negative what? Power. That for us to remove the what? The negative power, we'll take what? The reciprocal what? Of the number, which will give us this times 5 over 3. And if you want to multiply further, you can say that this is something as what? 1 times 5, 5, then 2 times 3, which will give me what? 6. So this is my what? Final answer. Or I can actually use cancellation method. Just come to this place. I have 5 here, cancel out, 5 cancel out. Then I have 2 in 5 places. We'll cancel out the 5 2's, remaining 1. At the end of the day, I will now have 5 times I will now have 2 times 3, which will give me 6, and then have the 1 of the 5 remaining, which will give me 5. But if you want to follow the laws of indices to solve this particular one, you can as well solve this. But it's always convenient to use the law, because when you have large numbers, like let's say 2 raised to power a very large number, you cannot start multiplying the number this way. You end up wasting all the whole time in this world solving such problems. Okay, that is that for now. We're going to pause it at this point. In our next class, we're going to continue. If you have any question, drop it at the comment section. If you have not subscribed to the channel, do well to subscribe, so that whenever we drop the content like this, you'll catch it up immediately. Thanks for joining. See you in our next class. Bye for now.